Hello everyone, now we are going to start our next chapter, that is arrays and our first data structure. So let us understand what is the meaning of arrays and where we use arrays. So let us consider a scenario that I want to store the marks of 3 subjects. Let us consider I want to store the marks of maths, physics, chemistry. So to store the marks of a particular subject, I can create its variable of that particular data type. So I can create that int math. This will store the marks of maths. Let us consider the marks are 99. After that, int physics. This will hold the marks of physics, right? 98. After that, finally, chemistry. Chemistry, CHE, let us consider 95. So I can create the variables of particular subject to store the data in that particular data type. So I can create the variables, right? Now here's the catch. I want to store the data of 50 subjects because in engineering we almost study around 50 subjects, right? So how I can store the marks of 50 subjects? Because if I create 50 variables here, if I create 50 variables like this, then it will become hard to access those variables and it might cause some difficulty. So to tackle that, we create array. So we basically just create an array of 50 subjects, 1 2 3 4 up to 50, and in that each block we store the marks of each subject. So this is how the working of array works. So I can store here the marks, max marks as 99, after that physics marks 98, after that 95, after that let us consider computer science Java language marks 99, after that and so on up to 50 subjects. So this is how we use arrays to store similar data type in a continuous manner, right? After that, this block, the data which we are storing in our block is known as element, and to locate each element in our array we give index for each element. So index always start with 0, so we are going to give indices for each element to in order to locate them. So 0 1 2 3 4 up to 49. So this is known as indices. And in Java or C++, most of the programming languages, we always start our indexes with 0. This is known as zero based indexing. Zero based indexing, right? So this is the concept of arrays. This is why we use arrays to store large amount of data. In order to store large amount of data and similar kind of data, we use arrays. So this is the definition of arrays. So the first line is list of elements of same type. Remember guys, suppose I want to store this, let us consider Jabir, after that Khan, after that 99, after that A. So here this is a string, after that this is also a string, and this is an integer, and A is the character. So this belongs to char, after that this is an integer, after that this is a string, and finally this is a string. So here we can see that the data provided here is dissimilar one. So string is different from integer and integer is different from character. So these kind of things I can't store in my array. The data which is provided should be similar, should be same. So I can store 9.1, 9.2 and 8 point something 4. So here I can store this because this is a float and this is accepted. The data which is provided here is similar or same. So the data should be same. After that, the second line. In the second line, placed in continuous manner. And remember guys, when we create array and when we give the assignment of each element for our array, memory allocation happens in continuous form. So in continuous manner, memory allocation takes place. Now I told you, now in the previous chapter in data types, I told you how memory allocate when it comes to variables. Memory allocates in the form of blocks for variables, and a block is known as we can visualize a block as a plot of earth, and each plot has its own unique address, right? Our house has our own address. So similarly, each variable has its own address, and we can treat our array. Let us consider that this is our array and these are the elements. So we can basically treat this element as a variable, and each element has its own address, and the memory allocation happens in the form of continuous manner. So to visualize it, to understand it, let us consider a scenario that I am storing uh, data of integer type. Let us consider 1 2 3, 4 and 5. So these are my elements in my integer type array. Here the memory allocation, let us consider that the location of this particular first element, let us consider that the location number is 1000. So we know that integer type will hold 4 bytes storage. The size of integer is 4 bytes. So the next element will immediately formed after 4 byte space is occupied. After that our next element will form, and the address will be 1004. After that third element address will be 1008. After that fourth element 1012. After that 1016. So you can see that after 4 bytes, after each completion of 4 bytes, the another variable, another element is taking place. So we can say that the memory is allocating in linear fashion, in continuous way. That's why we called array as linear type data structure. Linear type data structure. That is the reason we called our array as linear data structure. And whereas trees and stacks are not linear data structure, because the memory allocation happens randomly in when it comes to trees or stacks. So this is how memory allocation works in arrays. I hope you have understood the concept of memory allocation. It will happen in the form of continuous manner and in the form of straight line, basically I can say, right, in the form of continuous manner. And the indexes will always start with 0. So indexes is used to locate or to get through the element. So if I want to access the element 3, then 0, 1, 2, 3, 4, these are the indexes, right? So I will write, let us consider it the name of this array as ARR. So I can go to this element 3 by just accessing its index. So writing ARR of in the square brackets 2 will give me the element 3. So this is how we can access a particular element in our array by going through its index. So this is how the definition, and this is the need of using arrays. Now let us go into what are the operations we perform. So here we are going to learn how to create an array, how to take input, how to take output, and how to update array. And here another one, how to calculate length of my array. So length of my array, these all are the things we are going to learn in our next videos. So let us first of all study how to create array. So to create array, first of all let's go into our roots in our basics. So in first class we studied how to create a variable. So here how we create a variable, we just wrote integer data type. After if we are creating integer type variable, then we are going to write int data type, after it the name, and we are going to assign. This is how we create our variable. Similarly here, first of all we have to write data type, whether it is a integer, whether it is a float type, whether it is a boolean, whether it is a string, character, all those things first of all we have to declare. After it our array name. After it, remember guys, we have to give square brackets. You can see in your keyboard after P button there is a square bracket. So you have to give square brackets. After it is equals to new. New will tell me that I am going to create a new array and allocate memory, allocate continuous memory. So new keyword will tell me that this is array and have to allocate the memory in continuous fashion. So new is the keyword which will tell me that this is the array and memory allocation happens in continuous manner. After a data type, here if I am writing int, then here I have to write integer. And now in the again square brackets, in the square brackets I am going to give my size of the array. So how many elements I am going to create. If I am going to create 50 elements, if I am going to create 100 elements, the size of the array should be given before, declared before. So let us consider example that I am going to create a marks of 50 subjects. So how I am going to create array, this is how I am going to create array. Int marks, after that square bracket is equals to new keyword. After that int type, int data type. In that I am going to store 50 subjects marks, right? So I am going to write 50. That's all, statement terminator. So this is how I will create array. And these are the four different ways we can create arrays. So here in the first example you can see that we have create array without giving here we have created array marks is equals to int marks. Similarly, in our example, we have created here. After that, if I directly want to store the number or marks of the of particular array, then I can write it as int marks square brackets, after it is equals to, and I can directly give the elements 1 2 3, and in this I don't have to give the size of a particular array. And Java compiler will understand that the size of this array is 3. The elements totally present in this array is 3. So if I don't give the size of the array, and in the place of size I will, if I give the elements directly, then our compiler will understand that there are how many elements are there present and what is the size of the array and all those things. Here similarly, in the third example, we have created integer data type. After it, more numbers is the name of my array, after it square brackets, and here Java compiler will automatically understand that there are 3 elements present. In the fourth example, we have created a string. After that, fruits is the name of my array. After that, square brackets is equals to, in the curly braces I have stored different strings: apple, mango, orange, and all those things. So here Java compiler will automatically understand that there are 3 strings present in our string type array. So let us code this thing and understand how to create array. In this I have imported java.util package. After it, public class java basics. After it, public static void main. Now first of all, I am going to create an array here. So let me write int. Int is the data type of my array, and I am going to store marks of 3 subjects. Marks of, first of all, 50 subjects. So let us consider marks is my name of the array. After that, square brackets is equals to new. After that, int, and what is the size of my array? 50, right? So just give 50 here. Now if I want to give the marks of maths, physics, chemistry, then I can giving or accessing elements slash assigning. You can also write it as assigning. So here I am going to give, suppose consider that the first element holds the marks of max. So marks of 0 index. In the square bracket I am going to give 0. It implies that in the 0 index I am going to give some value now. So on the 0 index I am going to give 99 as my max marks. After that, marks of 1. Now I am going to access my first index, right, is equals to 98. This will store my physics marks. After that, max of 3. Now 2 index, second index here, second is equals to 95. This will hold chemistry marks. This is how I am going to assign the marks at each index. In the previous code, I have created an array of 50 elements, 1 2 3 up to 50, and this is how I create 50 elements by just writing the name after square bracket and name new int 50. Now when I create array, the Java will store the value of each index as 0. So Java will put automatically 0 0 0 0 on each index automatically, right? After that, I have declared that this is my 0 index, right? 0 1 2 3 4 5. Let us consider that 0 index will hold max marks. After that, this will hold physics marks, and this will hold chemistry marks. Now what I did that I have assigned the marks values. So marks of 0 is equals to 99. So here in the place of 0, 99 will be there. After that, marks of 1, I am accessing my elements through my indexes. These are my indexes, right? Marks of 1 is equals to 98. So here in the place of 0, 98 will now get assigned. After that, marks of 2, chemistry marks, is equals to 95. So here 95 will get assigned. So this is how the memory allocation and assigning of variables work. Now how we can take input and how we can print output to our user. So here we have created int marks square bracket is equals to new int 50. Now I want to get max marks from my user. So to do that, let me create my scanner sc is equals to new scanner in that system.in, in that system.in and parenthesis. So I have created my scanner class. We will study about classes objects in our OOPS chapter. Now I am going to take input from my user. So just as we used to get input from variables, similarly we are going to get inputs in the same way, but the only changes, we are going to access our elements through indexes. So if I want to get the marks of 0 index by the user, so I will write marks of 0 is equals to new sc dot next end. So marks of 0 is equals to sc dot next int. Right, after that let me here print system dot out provide math marks. Copy this thing, copy. Now let me take a marks from user physics marks, PHYSICS physics marks. Similarly in the index of 1 I am going to store physics marks is equals to sc dot next int. Right, similarly chem marks, chemistry, chem marks on the second index. Second is equals to sc dot next int. This is how we will take input from our user. Now the marks which I take from the user, let me print those marks, right? So here I am going to print the marks. So to print, let me print physics max comma physics comma chemistry marks are here plus just print marks in the square braces, give index. Index will access your element. After that plus marks of 1 plus marks of 2. This is how we will print the marks or the element of our array to the user, and we will use scanner as our input. Scanner sc is equals to system.in. After that by, as we used to do for integers, int a is equals to sc dot next int. Similarly we will access our elements of our array by getting its index. So marks in the square braces 0 is equals to sc dot next int. So whatever the value provided by the user, that will get stored in the first index. After that marks of 1 is equals to sc dot next int. So the marks provided for physics, that will get stored in the first index. First index is nothing but second element. After that third element for chemistry marks. So let me run this, save this code and run. So I have to give max marks. Let us consider my max marks is 98. After that physics marks 99. After that chemistry marks 99. So you can see that I have printed max. Let me give space here such that it will look good. Space, after that plus, again another space. Now save it again and run. Let me give max marks 99, 98, 99. So I can see that max marks, physics marks, chemistry marks are 99, 98, 99. So here we have taken the input from our user and assigned that particular value by accessing the index of my array. After that we have assigned the input given by our user to that particular element of my array. Now I have got the index for max, physics and chemistry, and finally I have printed the marks for the marks that we got from our user by just printing like this, system.out.print, and we can print our element by accessing the index marks in the square 0, that will give max marks. After that max in the square bracket 1, that will give physics. After that max in the square bracket 2, that will give us chemistry. So this is how we can access elements and we can print elements by going through its indexes. So we have seen that how to take input and output from our user. So to take input, we just build the scanner class, scanner sc is equals to new scanner in that system.in. After that, to take input from our user, we have created a marks array, right? So marks, and if I want to give the first element, that is, this is our array, right? 0, 1 and 2. If I want to give input to my first element, then I am going to write 0 index is equals to sc dot next int. So the user, whatever the value will be provided, that will get assigned in this variable. If I give 99, then in the place of 0th index, that is our first element, 99 will be get stored. So this is how we will give input to our user. So to get to print output we'll just write system.out.print and we'll print marks of 0. So at 0 index, whatever the value is, that will get printed. So here at the 0 index, the value is 99, so 99 will get print. So this is how we will take input and print output to our user. Now let us talk about when we pass array to as a parameter, as a argument to a function, what will happen. We studied about call by value and call by reference. We have studied in functions chapter what is call by value and call by reference. So call by value is Java will create a copy of that particular variable and pass it to my function. So whatever the changes that will happen in the function doesn't reflect in my main function. Whereas the meaning of call by reference is the whatever the changes that will occur in my function, that will reflect in my actual variable in the main function. So remember guys, when it comes to arrays, function calling, arrays are passed by call by reference. So if I change in the function, if I change any index of a particular array, then the actual array will get changed. So remember guys, that arrays will get passed by call by reference. So arrays will all get called by call by reference. Now let me create my array. Let us consider that int arr. Arr is my name of the array. After that I am assigning 1, 2, 3. Right? These are the elements, 3 elements present in my array. After that I am passing my let us consider that change function. So change will take arr as parameter, my array as parameter. Now I am going to create my change function. So public static void change. In the change function, the parameter is int arr. Right? After that, whatever the variable, whatever the array we are getting, I am going to change the index, the first index of my first element of my array. So let me access arr of 0, first element is equals to 100, 1000. Let me give 1000. After that, just return. I'm not doing nothing. I'm just changing the value. Of my first element. So if the array got passed by call by reference, then whatever the changes that will occur in the function should reflect in my main program. So in the main program, after calling a function, I am going to print each element of my array. So let me run a loop. I is equals to 0. After that, I should be less than or equals to arr dot length. So arr dot length is used to calculate the length of my array. So here the length is 1, 2, 3. So the length arr dot length should give me 3 as my output. After that, I plus plus. Here I am going to print each element arr of I. Save this thing. Now you can see that in the 9th line, arr of square brackets is equals to 1, 2, 3, 4. So the first element is 1. After that, I have called my change function. In the change function, what I am doing, I am going to change the first element value. So if the function is called by reference, then whatever the changes that will happen should reflect in my main program. So let me run this. We can see after running this, the value of first element will get changed. So you can see that the value is changed in my main function. Right? This is how the call by reference works. And remember guys, that arr dot length is used to calculate the length of my array. Here the length of array is 1, 2, 3. So arr dot length should give me the value of 3. Now we are going to see what is linear search. So to understand the meaning of linear search, let us take a scenario that when we are in school or when we are in college, we go to our college canteen, right? And if I want to order samosa, let us consider that in the menu, the first item is pizza, second item is burger, and the third item is sandwich, and the fourth item is samosa. So what I do, I will just go line by line. So first item is, if if my needed element is samosa, the element which I want is samosa. So I will scan line by line. So the first item is pizza, rejected. I will come into second item. Second item is burger, no. Third item. Third item is sandwich, no. Fourth item is samosa. Now I get the samosa, so I can order the samosa. So this is nothing but linear search. Going scanning line by line for a particular information or a particular element is known as linear search. Here, suppose let us consider that the key will be provided by our user, and this is our indexes, right? 0, 1, 2, 3, 4, 5, 6, 7. So I will search line by line. So this is our key. I will start searching for my key line by line, index by index. So here let us consider that this is my indicator. So this indicator will see whether the provided key is present or not. So here the provided key is 10. This is 2. No, if it is not present, then come into next index. So here key is 4 and element is key is 10 and element is 4. No, here come into next iteration, and in the next iteration element is 6 and the key is 10. No, next iteration element is 10, element is 8, after that key is 10. So no, the element is not matched with the key. After that, next my indicator will come into next index. In the next index the element is 10 and the key is 10. So both are same, both are the same. So if both are same, then return 4, return the index of that particular element. So this is how the question of linear search work. Here we are going to run a loop and we are going to check at each element if the provided key is same or not. If it is same, then immediately return the index, or else go into next iteration. So I can write the pseudo code as for, let us consider that this is my array and the name of the array is ARR. So I am going to run my for loop int I is equals to 0. After that, I should be less than ARR dot length. After that, I plus plus. In this, I am going to check if ARR of I am going to access each element by through its index, right? ARR of I is equals to key. If it is equals to key, then return its index, right? Else continue. That's how. This is how. If I didn't find the element in my array, then return -1. Return -1. So this is how the pseudo code for finding a particular element or matching the key with our element and returning its index, returning the index of the particular element which got matched. So this is the question of linear search, and the time complexity for linear search is big of n, because we are running our loop for n times, right? So suppose let us consider that there are n elements and nth element is our key. So we will run our loop for n times. So the worst case scenario is in the worst case scenario we are running our for loop for n times. So the time complexity will become n and space complexity will also become n, big of n. So we will study about space complexity and time complexity in detail in a separate chapter. But remember that having low time complexity or less time complexity and less space complexity is considered as a efficient efficient code. Here this will give me linear time complexity. So with increase in time, with increase in the size of our array, the time will get increased. So this is nothing but linear time complexity. And remember guys that the time complexity of linear search is big of n and space complexity is also big of n. And this is the pseudocode for finding the index of a particular given key. So let me create my public function, public static integer type function, because it will return the index of that particular element, right, which got matched by the key. After that, let me write my function name linear search. In the linear search, I am going to pass the array int arr as my parameter. After that, in the curly braces, so now I am going to create my function for linear search, public static. After that, integer type function, because it will return the index of that particular element which got matched by the key, right? So int type, return type. After that, my function name linear search. In the linear search, it will take two parameters, the array itself. After that, key, int key, int key. In this, I am going to run a loop for int I is equals to 0 and I should be less than arr dot length, arr dot length and I plus plus. In this, I am checking if my key is equals to arr of ith element. If it is equal, then return that particular index, that is I. Else next iteration. And finally, if my loop is completed and I haven't got the index of that particular provided key, then it simply means that the element is not present in my array. So if the element is not present in my array, then return -1. Now in the main program, let me create my array int arr is equals to, in the parenthesis, 1 2 3 7 9 7 9. Right, these are my elements. How many elements are present? 1 2 3 4 5. 5 elements are present here. Now I am going to call my function linear search. In the linear search, I am going to pass arr and key as 7. So the index of 7 is 0 1 2 3. So first element 0, second 2 3 1 2 0 1 2 3. So the index for 7th element is 3, right? Because this is a 4th element and the index is n minus 1, that is 3. Now I am going to store the index of that particular value. So index is equals to linear search. So whatever the value returned by the linear search, I am storing it in index variable. After that, finally I am printing index of the provided key is plus index. That's all. Save this thing and run. You can see that we got our index as 3, because the index of here in the array, the index of 7 is 3, because index starts with 0, right? So for element 1, the index is 0, element 2, the index is 1, and element 3, the index is 2, and for element 7, the index is 3. So we got our output as the index of the provided key, that is 7, is 3. So if I provide here, let us consider 1. If I provide 1, then it will give 0, right? Because first element, 0th index. Yeah, you can see that index of the provided key is 0. Suppose if I pass some key which is not present in my array, then it should give me -1. You can see that the index of the provided key is -1. It simply means that the element is not present in my array. So in this question, we have to print the largest number in our array. So in this array, we can see that the largest number is 6. So we have to print 6 as our largest number. So what is the logic behind it? The logic is comparison. So the first step in our question is we are going to create a largest type integer. Largest integer which will hold -infinity. So here in Java we have a concept of -infinity and +infinity. So -infinity is nothing but the most negative number, the most or least negative number that can be possible is known as -infinity, and we will represent it as integer dot min value. And the highest value that can be possible in integer is represented by +infinity, and for that we will write integer dot max value, right? These things can be accessed by utility package. We imported, right, import java.util.in. By using that, we can import these things. So if you didn't write import.java.util, then these might show you error by writing this integer dot min value and integer dot max value without importing our Java package. That might show you error. So it is important to import our Java package, right? Import java dot util dot star. So it is important to write that line. Now in this question we are going to first of all create a largest uh, integer variable that will hold the value of minus infinity. And the second step is we are running loop. We are running a for loop for int I is equals to 0. After that I should be less than n, where n is the size of my array. After that I plus plus. In this we are going to compare if my largest is less than ARR of I. Let us consider the name of my array is ARR. If largest is less than ARR of I, then assign the value of largest as the given element ARR of I. Simple. This is how we are going to find out the largest element present in our array, and finally print the value of largest. Let me dry run this. By doing dry run you will understand it better. Now here, this is my 0 index, first index, second index, third index, fourth index. So these are my indexes, and here initially largest is equals to minus infinity and I is equals to 0. So you can see that largest minus infinity is less than ARR of 0, that is 1. So minus infinity less than 1? Yeah, absolutely true. If the condition is true, then change the value of large by assigning the value of ARR. So ARR value now is ARR of 0 is 1. So I am going to assign the ARR of 0 value to my largest. So minus infinity will get changed to 1. So now largest will become 1. After that I will be incremented by 1. Now the ARR of 1 is 2 and largest is 1. So I can say that 1 is less than 2. Again the condition here is true. If condition is true, then largest will become 2 and I will become 3. After that here ARR of 2 is 6 and largest is 2. Again the condition, if condition is true, that is 2 is less than 6. Yeah, condition is true. Then my largest will become 6 and I will get incremented by 4. I will I will be incremented by 3 here too, right? So I will be incremented by 3. Now ARR of 3 is 3. Now 6 is not less than or equals to 3. So nothing will get changed and I will become 4. Now ARR of 4 is equals to 5. Now the element at present at ARR of 4 is 5. So 5 is not greater than 6. So the if condition is false, so we change nothing. After that finally we are printing the value of largest. So the value of largest is 6. So this is how we will get the largest of a number present in our array. Let me create my largest function, public static int, because this will return the largest number present in our array. After that let me create largest is the name of my function. After that int ARR, it will take a array as parameter. After that I am going to write int largest is equals to integer dot min value minus infinity. After that I am going to run a loop for int I is equals to 0 and I should be less than ARR dot length. After that I plus plus. In this I am going to compare if largest is less than my ARR of I. If this is true, then do largest is equals to change the value of largest as ARR of I. And finally after loop completion, print the value of largest or return the value of largest. Return the value of largest. That's all. And in the main program, let me create my array int ARR is equals to 10 0 9 8. After that call largest function, pass ARR, and finally let me create int l that will hold the value of the value returned by the largest function, and print largest value in the array is print l value. That's all. Save this and run. You can see that the largest value which is present in our array is 10, and we got the output largest value present in the array is 10. So our code is working fine, and this is how we will find largest of the given number. Now I want you guys to do a question and try it yourself. So in the place of largest, I want you guys to find the least or the minimum value of the given function. So how you cannot do this? Here, to find the largest, we used integer dot min value. So integer dot min value is nothing but minus infinity. So similarly, to find the minimum of the minimum number in the given array, we use integer dot max. So I want guys to pause and do the video. I'm gonna do this, finding minimum element of the array, but I want you guys to pause the video right now and try it yourself. After that, now I'm going to create public static void void minimum min. In this int arr it's gonna take, and after that I'm going to create a variable. Let us consider that min will give me the least element present in our array. So min will hold plus infinity integer dot max value. After that I'm going to run a loop for int I is equals to 0 and I should be less than arr dot length. After that I plus plus. In this I am going to compare if our min is greater than arr of I, then do min is equals to arr of I, and finally after loop completion print my min value. You can write minimum is. Save this thing and let me call my minimum function min and pass the value of arr. Now here in the array the minimum value is 0, so my output will be, you can see that largest value is 10 and the minimum value is 0. So this is the code for finding the largest and the minimum value or the number present in our array. Now let us talk about binary search. So binary search and linear search are the two searching techniques which are used to search a particular element in our array. If that particular element is present, then we will return the index of that particular element. This is known as searching. So we have already studied linear search, and now we are going to study about binary search. So before we go into the deep dive into the binary search, let us understand that the time complexity of binary search is big of log n, whereas the linear search is big of n. So when it comes to time complexity, binary search is more efficient. After that, the space complexity of binary search and linear search is same, that is big of n. So the time complexity of binary search is a little bit efficient when we compare to linear search searching technique. Now here is the catch, that binary search is only applicable to a sorted array. It means that the array which is provided should be in increasing order or should be in decreasing order. Let us consider that there is array 1, 2, 3, 4, 5. Then we can we can apply binary search to this array because it is sorted in ascending order. So the elements are increasing line by line. So we can apply binary search here. But let us consider another array 3, 0, 5, 1. Here we can't apply the binary search here. So to search a particular element in this array, we have to use linear search, and we can't apply binary search because this is not a sorted element. This is an unsorted array. Because that's why we can't apply binary search. So remember that before we go into logic and the working of binary search, remember that time complexity of binary search is big of log n. After that, space complexity is big of n. So the time complexity is little bit efficient, and the code of binary search is little bit efficient when compared to linear search. But the only catch here is binary search is only applicable for sorted array. So this is how these are the things we have to remember before we go into binary search. Now let us understand the logic for binary search. To visualize how binary search works, we can take a dictionary example. So in dictionary we have a lot of words, right? And a lot of words start with different letters. So let us take there are different letters. Let us take apple, banana, after that cabbage, uh, uh, let us consider that duck, fruits and animals, after that elephant. Now I want to search cabbage in my array. This, let us consider that this is the array. Now I want to search cabbage in my array. So what we used to do in linear search, we used to go on to each element, but in binary search we don't do that. We just see this is our key, right? This is our key. So we will check whether my key is lies in the right side or in the left side. If it is in the right side, then we'll go towards the right side, and if it is in the left side, then we will go into left side, right? This is how the basic logic and basic structure of binary search. I will tell you again. Suppose there are many letters, right? A to Z, there are many words in dictionary. Suppose I want to search a letter which starts a word which starts with the letter M. Suppose I want to search mango. So I don't need to start from the letter A, B, C, D, E, F, G, H, and all those things in the linear fashion. I can come towards the letter which is nearer to my mango word. So I will come towards the letter which is nearer to M letter, and I will start searching from here. So this is the logic for binary search. Now let us understand for the given array. Now this is our given array, right? This is our given array. These are the indexes 0, 1, 2, 3, 4, 5, 6. Here remember we have to take three things that are, first one, starting index. So we will create three variables. Starting index. So starting index will variable start will store the data of starting index. Now here the starting index is 0. After that ending index is equals to 6, right? So can I write that total size is 7? So the ending index is n minus 1, that is 7 minus 1. Yeah. So starting variable will hold the starting index, after that ending variable will hold the ending index of my array. Now I am going to create a mid variable, which will hold the average of this, that is starting plus end divided by 2, right? This is my first step, and the second step is here we have given key is equals to 10 and we have to search key. So what is the mid value here? This is my starting value and this is my ending value. So can I write that our mid is equals to 0 plus 6 divided by 2, that is my mid is 3. So my mid here is, this is my mid is 3. So we have calculated our mid by taking starting index and ending index, right? Up to this I hope you have understood. Now I am going to check in the second step. I am going to check I know what is my key is. So I already know that the given array is sorted. So I am going to check if for, let us consider that this is my ascending array. The values are increasing after each indexes, right? So here we can see that the values are increasing. So 2, 4, 6, 8, 10, 11, 12, 14. So the second step is I am going to compare. So can I compare that if my key is, the value of key is greater than my let us consider that this is my array and this is my mid index, right? So ARR of mid index, it means that my key lies after my mid element, right? So this is my mid element. If key is greater than the mid element, then can I say that my key will lie after mid? So if this condition is true, then the step we are going to proceed with is we are going to change the value of start is equals to start mid plus 1. This is the step we will proceed. If in the second step, that is if key is less than our mid, that means that our mid is greater than the value of key. That implies that this is our mid and our key lies here. So in this scenario, we will do one thing, that is we will change the value of end. So when key is greater, we will change the value of start. When key is less than the mid, then we will change the value of end. So this is the logic here. So we will do end is equals to mid minus 1, mid minus 1, right? This is the logic here. And in the third step, if we found our key, that is if we found our key is equals to ARR of mid, then simply return mid. That's all. Mid is nothing but our index, right? If we haven't found, then finally return -1. So this is the pseudocode and the logic of binary search. So I can rerun if you want. So this is our array, right? 4 6 8 10 12 14. This is our array, right? This is my starting index 0, and this is my ending index 6, and this is my mid, that is 3, right? So this is my key, this is my key. So first step is we have calculated all those things. After that, I am going to compare. In the second step, I am going to compare if key is greater than the mid. So if key is greater than, so this is my key and this is my mid. So can I say that my key is greater than my mid element? So if the condition is true, then I am going to only search on this array. So this array will become, I am going to shorten the array. So our start will become start is equals to mid plus 1. So what is mid? 3. So 3 plus 1. So start will become 4. So from this, start will become here the value of 4, right? Start will become here 4. Now our mid will also get changed. So what is the formula for mid? Mid is equals to start plus end. So here the value of start is changed, so automatically mid will also get changed. So 4 plus the value of end is 6 by 2, that is our value of mid is 10. 10 by 2, that is 5. So our array is this is my 10th element 12 14. So this is my end 6, and this is fifth index. Now this is my mid. After that, this is my start, right? This is my start, the value of start is 4. Now here, this is my key, this is my key, and this is my mid. So in the second step, you can see that if key is less than, here the scenario is our key is less than our middle element. If this is condition is true, then what we'll do, end is equals to mid minus 1. Now I will change this array as we'll do end is equals to 6, right? So we are going to change the value of 6 by mid minus 1, that is the value of mid is 5. So 5 minus 1. Now end will become 5 minus 1, that is 4. After that, the value of start is 4, and now our mid will become mid is equals to 4 plus start plus end, that is 4 plus 4 divided by 2. So my mid will become 4, that is our array again gets shortened, our array will get reduced again. Now this is my start, this is my end, and this is my mid. So the value of mid is 4, end is 4, and start is 4. So what is the fourth index? That is 10. So this is our key, right? So we got our key. So finally, what is the value of mid? Mid value is 4. So we will return 4 to our user. So this is the working of binary search. I hope you have got the logic, and if you didn't, then rewind the video and watch it again. You will definitely get the logic. Now this is the code. So first of all, we will create a start variable. Start is equals to 0. We will initialize it with 0. This is our array, right? 0, 1, 2, 3, 4, 5, 6, and end is equals to 7 minus 1. Total number of elements are 7, that is n is equals to here 7, that is 6. Now we will run a while loop. So we are going to change the values of start, end, and mid, right? So to do that again and again, we will use loop. Now the condition here is while our start is less than or equals to end. This is our condition in that curly braces, and we are going to find mid. What is the formula? We already studied that start plus end divided by 2. This is the formula for finding mid. After that, we are going to compare. If mid is equals to key, then return mid. That's all. if our mid is greater than key, that is this is our, let us consider that this is our mid and our key is less than, our key lies somewhere here, then what we will do, we will change the value of end, that is our key is less than mid. If this is the scenario, then we are going to change the value of end. Here end is 6 and start is here. So if our mid is greater than the value of key, then we are going to do end is equals to mid minus 1. Mid minus 1. This is the step we're gonna perform if mid is greater than 0. If in this condition, if mid is less than key, let us consider that this is our key, then we are going to change the value of start by mid minus start minus 1. So in this step we are going to do start is equals to mid plus 1. This is the scenario. Now let me create my function public static int will because this will return the index of that particular element, right? After that, binary search. My function name is binary search. In that I am going to pass array int arr. After that, int key. I am going to pass my key. In this, I am going to create first of all a start variable, start start is equals to 0. After that, int end is equals to here arr dot length, that is nothing but n value minus 1. After that I am going to run my loop while my start is less than or equals to end. In the loop I am going to check if first of all, before that we have to create a mid variable, right? So int mid is equals to start plus end, start plus end divided by 2. After that we are checking if our mid arr of mid is equals to key, then simply return my mid value, that's all. Here after that, else if our mid arr of mid is greater than our key, that means our key is less than my mid. In this condition I am going to change the end value, end is equals to mid minus 1, right? That's all. And finally final statement, else if arr of mid is less than my key, that is our key is greater than our mid, then I am going to change the value of start is equals to mid plus 1, mid plus 1, that's all. And finally, if we didn't find the key after while loop completion, then finally return minus 1, that's all. And in the main function, let me create my array arr is equals to 2 3. The array should be sorted. This is the only condition for binary search. The given array should be sorted in either ascending order or in descending order. This is the only condition for binary search. So I am going to give 1 2 3 4. So total number of elements are 4. After that I am going to call let me create my index variable that will store the value returned by my binary function, binary or arr. After that I am going to pass my key as, let us consider 2. Now I am going to print my value index of two is index. Save this thing and run. Let me run this. We got our output as index of 2 is 1. You can see that the index of element 2 is 1. So the answer is correct. So remember guys that binary search is more efficient than linear search, but the only drawback of binary search is it is only applicable for sorted array.